What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-008 certification. So let's get into it. In this video, you're going to learn about the core security concepts pertaining to confidentiality, integrity, and availability. All right, so let's talk about confidentiality, integrity, and availability, also known as the CIA triad. So for most of today's corporate networks, the demands of e-commerce and customer contact require connectivity between internal corporate networks and the outside world. Today's corporate networks tend to be large and interconnected with other networks, and they typically run both standards-based and proprietary protocols. In addition, the devices and applications connecting to and using corporate networks are continually increasing in complexity, and it will be unusual for a corporate network not to need network security. So, like I stated earlier, CIA, this refers to the three primary goals of network security, which are confidentiality, integrity, and availability. And the following information is going to explain these goals in more detail. So let's talk about confidentiality. So data confidentiality. This involves keeping data private by physically or logically restricting access to sensitive data or encrypting traffic traversing a network. A network that provides confidentiality would, for example, do the following. We would use network security mechanisms such as firewalls and access control lists to prevent unauthorized access to network resources. You would require appropriate credentials such as username and passwords to access specific network resources. You would encrypt traffic such that any traffic captured off the network by an attacker cannot be deciphered by the attacker. And confidentiality can be provided by using encryption. Encryption allows a packet to be encoded in such a way that it can be decoded by an intended party. However, a malicious user who intercepted an encrypted packet in transit would not be able to decrypt the packet. The way most modern encryption algorithms prevent decryption by a third party is through the use of a key. Because the encryption or decryption algorithm uses a key in this mathematical calculation, a third party who does not possess the key cannot interpret intercepted data that is encrypted. And encryption, this has two basic forms. You have what is called symmetric encryption and asymmetric encryption. All right, so let's talk about symmetric encryption. So symmetric encryption, this is faster than asymmetric encryption. And the word symmetric in symmetric encryption, this implies that the same key is used on both the sender and receiver to encrypt or decrypt a packet. And examples of symmetric encryption algorithms include the following. First one is called DES, and that stands for Data Encryption Standard. And this is an older encryption algorithm developed in the mid-70s that uses a 56-bit key. And it is considered weak by today's standards and has been deprecated. Next, we have Triple DES, and this was developed in the 1990s. And this uses three 56-bit DES keys for a total of 168 bits. And this was originally considered a strong encryption algorithm. However, the security of Triple DES varies based on the way it is implemented. Specifically, Triple DES has three keying options. All three keys may be different, which is keying option 1. Then you have two of the three keys may be the same, which is keying option number 2, or all three keys may be the same, which is keying option number 3. And that is to maintain backwards compatibility with DES. Because of the high computational overhead of Triple DES, many companies have moved directly to the much faster AES instead of using Triple DES. And next we have AES, or the Advanced Encryption Standard. And this was released in 2001, and this is the preferred symmetric encryption algorithm. AES is available in 128-bit key, 192, and 256-bit key versions. This technology is being used more and more for many different applications, including wireless, mobile, VPNs, and web security implementations, and it is popular because of its overall strength and its ability to provide various levels of security based on the key length. And for lower security environments, you can use the 128-bit key AES, but the 256-bit key implementation, this is considerably almost unbreakable. And this picture on your screen right here, this provides an example of symmetric encryption where both parties have a shared key to be used during a session, which is called a session key. And as a side note, another widely deployed encryption algorithm is called Pretty Good Privacy, or PGP, which is often used to encrypt email traffic. In PGP, it uses both symmetric and asymmetric algorithms. And the free variant of PGP, this is called New Privacy Guard, or GPG. All right, next let's talk about asymmetric encryption. So asymmetric encryption, this is slow compared to symmetric encryption, but provides better security. And as its name suggests, asymmetric encryption uses asymmetric or different keys for the sender and receiver of a packet. Because of its speed, asymmetric encryption is not typically used to encrypt large quantities of real-time data. Rather, asymmetric encryption might be used to encrypt a small chunk of data that's being used. So for example, to authenticate the other party in a conversation, or to exchange a shared key to be used during a session, after which the parties in the conversation could start using symmetric encryption. One of the most popular asymmetric encryption algorithms in use today is called RSA, and its name comes from the last initials of its three inventors, who are Ronald L. Rivas, Adi Shamir, and Leonard M. Adelman. And RSA is commonly used as part of what is called a public key infrastructure system, or PKI, and specifically PKI uses what are called digital certificates and a certificate authority for authentication and encryption services. So here's an example of how asymmetric encryption works. So when client A wants to communicate securely with server 1, the following steps will occur. So client A receives server's 1 digital certificate, then server 1 sends its digital certificate, and client A knows the received certificate is really from server 1 because the certificate has been authenticated or signed by a trusted third party, which is called a certificate authority. Step 3, client A extracts server's 1 public key from server's 1 digital certificate. The data encrypted using server 1's public key can only be decrypted with server 1's private key, which only server 1 has. Step 4, client A generates a random string of data called a session key. Step 5, the session key is encrypted using server 1's public key and is sent to server 1. And then step 6, server 1 decrypts the session key by using its private key. Now, at this point, both client A and server 1 know the session key, which can be used to symmetrically encrypt traffic during the session. And as a side note, symmetric key algorithms, they are faster and often used for bulk encryption of data. And asymmetric key algorithms, they are slower and are often used for initial security transactions, such as authentication. All right, next let's talk about integrity. So ensuring data integrity, this involves making sure data has not been modified in transit. Also, a data integrity solution might perform origin authentication to verify that traffic is originating from the source that should send the traffic. And examples of integrity violations include the following: modifying the appearance of a corporate website, intercepting and altering an e-commerce website, and modifying financial records that are stored electronically. And hashing, this is one approach to providing integrity to data transmissions crossing a network. Specifically, hashing takes a string of data such as a password and runs it through an algorithm. The result of the algorithm is called a hash or a hash digest. If the sender of that data runs a hashing algorithm on the data and sends the hash along with the data, when the recipient receives the data, he can also run the data through the same hashing algorithm. If the recipient calculates the same hash data, he might conclude that the data has not been modified in transit. That is, he has confirmed the integrity of the data. And note that a hashing algorithm produces a hash digest of the same length, regardless of the size of the data that's being hashed. And two hashing algorithms that are commonly used, the first one is called Message Digest 5, or MD5, and this creates a 129-bit hash digest. And then you have Secure Hash Algorithm 1, or SHA-1, and this creates a 160-bit hash digest. And hashing by itself, however, this does not guarantee data integrity because an attacker could intercept a string of data, manipulate it, and recalculate the hash value based on the manipulated data. The victim would then determine that the hash is valid based on that data. And to overcome this limitation of pure hashing, Hash Message Authentication Code, or HMAC, this uses an additional security key in the calculation of a hash value. Therefore, an attacker would not be able to create a valid hash value because he would not know the secret key. And other variants of hashing algorithms, such as SHA-256, this involves longer digests. So in cryptography, a bigger digest, this implies better security. All right. And finally, let's talk about availability. So the availability of data, this is a measure of the data's accessibility. So for example, if a server was only 5 minutes per year, the server would have an availability of 99.999%, or the 5 nines of availability. And here are a couple of examples of how an attacker could attempt to compromise the availability of a network. They could send improperly formatted data to a network device, which would result in an unhandled exception error, or they can flood a network system with an excessive amount of traffic or requests, which would consume a system's processing resources and prevent the system from responding to many legitimate requests. And this type of attack, this is commonly referred to as a DOS attack or a denial of service attack. So that was my video where we talked about the core security concepts pertaining to confidentiality, integrity, and availability.